Dear learners, welcome back. Today we are going to solve one question which has been previously asked in the year 2012 for 20 marks, and this is one of the most important questions asked in ESE. So let's first understand what the question is and then we'll solve this question. The question says that gates of lock are 5 meter wide and 6 meter, there's actually a printing mistake over here, it is deep, 6 meter deep, and when closed at an angle of 120 degree. So let me tell you what is this. There is a dam or a reservoir, you can say, like this, and this is the upstream side, and then there is downstream side. The water is flowing from upstream to downstream side. This is all full of water. There is a gate which is at an angle of 120 degree. What is this? 120 degree. This angle is 120 degree. Now each gate is held by two hinges placed at the top and the bottom of the gate. If the water levels are 6 meter and 4.5 meter on the upstream and downstream side respectively, so the water level is 6 meter over here and 4.5 meter over here respectively, determine the magnitude of the forces on the hinges due to the water pressure. So what we have to find, what is the forces acting on these hinges. Before solving this question, let me explain you the figure. So this is the figure. This angle is 120 degree. This is the plan view. Plan view means you are looking at the figure from the top. So let's look at this figure from the elevation side. Elevation side means you are looking at the figure from this side. Here is your eye and you are looking at the gate. Here is what you are going to see. This is the upstream side, this is the downstream side, and the water level in the upstream side is 6 meters and the water level in the downstream side is 4.5 meters. Okay, let me just tell you, the width of the gate is 5 meters. So this length is 5 meter, this slanting length is 5 meter, this length is 5 meter. So while looking from the side or the elevation side, you are not looking at the 5 meter length, but what actually you are looking at is the projection of this 5 meter here. You are looking at the projection of the 5 meter over here. So what it will be, or this length will be, this is 60 degree by symmetry, this angle is 60 degree, so this angle will be 60 degree, so it will be 5 cos of 60 degree, right? This is 5 cos of 60 degree. So you are looking at the 5 cos of 60 degree. This length will be 5 cos of 60 degree. So you are not looking at the 5 meter width of the gate. You are just looking at the elevation view in which the width of the gate is 5 cos 60 degree. Now once you have understood this, these are the hinges which are shown at the top and the bottom of the gate, and you have to find what is the forces acting on these hinges. Now let's understand the same figure from the front view. This is the front view. You are looking at the gate from this side. This is your eye and you are looking at the figure from this side. So this is the front view. There are two gates and there are hinges on the top and the bottom side of the two gates. Okay. Now what is this length? Can anyone guess what is this length? Is it 5 meters plus 5 meters is equals to 10 meters? No, it's not that. It's 5 into, this is 60 degree, this is 60 degree, that means it's total 120 degree. This length is this one. This length is 5 into sine of 60 degree. So it is 2 into 5 into sine of 60 degree. This is the width of the gate. And what is the height? Height is same. The 6 meter is the height. Since you are looking at the gate from the downstream side, you are looking also having the water table with the height of water stream, which is at 4.5 meter. So this is the front view of the gate. Now let's start solving this question. So this is the elevation of the gate. This is the stress diagram for the upstream side. This is the stress diagram for the downstream side. Let me write it here. This is upstream side, this is downstream side. So upstream and downstream side. So what is the stress acting at this point due to all the water column above it? Is it rho gh? Is it the stress acting on the bottom of this stress diagram is rho gh? So what will be the total stress acting on the gate? The total stress acting on the upstream gate will be the area of this diagram, right? This stress diagram. So force will be how much? Force is stress into area, right? So what is stress? Stress is rho, half into base into height. Total stress will be the area of this triangle, half into base. Base is how much? Rho gh. Or what is h over here? H is the height of the water in the upstream side. So it is 6 meters. The height of the column is 6 meters. So 6 into gamma w will be the stress at the bottommost point into height again. This will give you the area of the triangle or the total stress. This will give you the total stress. Now, if you multiply this stress with the width of the gate, this is just the stress area, total stress. But if you multiply with the depth, that means if you multiply the stress which is acting with this width, you are going to get the total force acting on this gate, on the both the gates. Okay, so we have got the stress. So this is the stress diagram, and if you multiply with this width of the gate, 2 into 5 into sine 60 degree, you are going to get the total force acting. So it will be 2 into 5 into sine 60 degree. You are not going to multiply it with 5 meters, 2 into 5 meters. Rather, you are going to multiply it with 5 into sine 60 degree, because the forces acting on the gate will get distributed. Let me explain you this. The hydrostatic forces will act normal to the gate. Okay, it will be having two components. The component x, force in the x direction, and there will be a component in the y direction. Since the water level is same in all directions in the upstream side, water level is same in the upstream side and same in the downstream side, this force in the Fy will get cancelled out, and only there is a difference in level in Fx. So this force will be considered. Okay, force Fy will be cancelled out, and the only force which will cause reaction in the hinges will be force in the x direction. And why this force Y will be cancelled out? Because as you can see here, it's full of water. Let me just explain you this. It's full of water over here. So everywhere it's water, it's filled with water. So anywhere the forces will cancel each other. So forces in the y direction will be 0, nullified, and forces on the x direction will act in this direction. That means it will act on the projection of the gate on the y axis. This is the y direction, that means y axis. So you have to take this width of the gate. And what is this width of the gate? It is 2 into 5 into sine 60 degree, as I have explained you before. So this stress into area will give you the total force. Let me just calculate this total force for you. So let me write force upstream will be how much? Half into 0.5 into 6 into what is the value of gamma W? The value of gamma W is 9810 newtons. Okay, so 9810 newtons into again 6, then 2 into 5 into sine of 60 degree. So this will give you 15 227 point something something newtons. So if you convert it into kilonewton, you will get 1529. This is a huge number, so I am converting it into kilonewton. 227 kilonewton. Okay. Now let's find out the force for the downstream side as well. For the downstream side, the stress at this point will be how much? It is rho gh, that is gamma w into what? Height of the column of water, that is 4.5. So what is the total stress acting on the gate from the downstream side? It is half into base into height. So it will be half into what is the base? Base is 4.5 into gamma w. 4.5 into gamma w into height. What is the height of the water? It is 4.5. Now this is the stress, total stress acting on the gate from downstream side. This is the stress. If you multiply this stress with the depth of the gate of both the gates, I am telling you, that is same, 2 into 5 into sine 60 degree, you will get the total force. So 2 into 5 into sine 60 degree. Actually, this is the width of the gate. So you are going to get the total force. So let me just calculate this total force for you. It is 0.5 into 4.5 into, again gamma w is 9810 into 4.5 into 2 into 5 into sine 60 degree. Sine of 60 degree. This will give you 860 190 Newton. If you convert it, you will get 860.190 kilonewton. So once you have got the forces, let me write it down. This force on the upstream side will act at from the centroid of this triangle, right? And you know that the centroid of the triangle lies at a distance of 1/3 from the base of the triangle. 1/3 of the base means 1/3 of 1/6. So this force will act at a distance of 2 meters from the base, right? What is that? What is that force? 1529.227. Let me write it down here. 1529.227 kilonewton. And similarly, the force in the downstream side will act at a distance of 1.5 meters from the base, because 1/3 of 4.5 is 1.5, right? And what is that force? That force is 860.190 kilonewton. 860.190 kilonewton. Now let this point be point number A, let this be point number B. You have to find the reactions at the hinges, right? Now let me remind you, there are two hinges over here, not just one. You can see just one hinge, but there are two hinges actually on the top. These are the two hinges on the top, and there are two hinges on the bottom of the gate. Okay, so let's take 2RA, reaction at A, and this is 2RB. Okay, now let's take, you have to find out RA and RB. That's all. How will you find it out? You have to take the moment either about point A or either about point B. So let's take the moment about point B in order to find out the reaction at A. So taking moment about A. Sorry, let's take the moment about B. So this force and this distance about this point is acting in the clockwise direction, right? This force is trying to rotate in the clockwise direction. I hope you all know how to take the moments. If someone is not understanding, please comment and I'll explain you this. So taking a moment about B, the clockwise moment is caused by force in the upstream side. So 1529.227 into 2, this is the clockwise moment, must be equals to 2 into RA, 2 RA into what is the perpendicular distance about, so perpendicular distance is 6 meters, plus force, a moment due to this force, downstream force, is 860.19, and what is the distance? Distance is 1.5. So once you calculate this, you are going to get the value of RA. RA is 1529.227 into 2 minus 860.19 into 1.5 by 2 into 6. So if you solve this, you will get the value of RA. Let me just solve it for you. 1529.227 into 2 minus 860.19 into 1.5 by 2 into 6. 147.347 kilonewton. This is kilonewton because you have taken the units. This was in kilonewton and this was in meters. Okay, so meters will get cancelled out and you will be left in kilonewton. Now similarly, if you take the moment about point A, you are going to get a reaction at B, or you can further do one thing. You take the summation of forces on both sides to be equal. Okay, you take the summation of forces on both sides to be equal and you will get the reaction at B. Let's do that. So forces on the summation of forces on the x direction will be 0. We will take summation of all the forces along x direction is equals to 0. So what is the force here? 1529.227, 1529.227. this is the force acting. What is the force in the downward direction? So this was the reaction. So 2 into reaction, it is acting in this side. This reaction is, I'm just sorry, just I didn't mention that this reaction was acting in this side. So 2 into RA means 2 into 147.34, 2 into 147.34, this is acting, plus this force which is again acting along the negative x-axis. So it is 860.19. So 860.19. Now this hinge, let's take the force in this hinge is acting in this direction. We have assumed this. So this is the reaction at B. Okay, plus 2 into reaction at B. So let's solve this to find out what is the reaction at B. So reaction at B will be 1529.227 minus 2 into 147.34 minus 860.19 by 2. If you solve this, you will get, let me just solve this for you and let's see what the answer is. 2 into 147.34 but okay, there is another minus 860.19 by 2 is equals to 187. This is 187.178 kilonewton. So this is the answer. This is the final answer. So this is the reaction at the bottom hinge and this is the reaction on the top hinge. I hope you understood this question. This was very important question asked for 20 marks in the ESE examination. If there is any doubt, do comment in the comment section. Till then, bye-bye and have a nice day.